Good evening. My name is Nazara Agusta. I'm from IS-43 International. Today I'm gonna explain and demonstrate based on a case study that has been given. Today we're gonna do normalize the data based on this table. This is called the unnormal data because it is incomplete. As you can see, there are several data that has been blank, and then based on here, yeah, it's still incomplete. So the data just make it as it is. And right now we're gonna normalize it into different kind of steps in a different form. Right now, based on this normalize, we're gonna go to the first step, is the first form. The first form is, because this is the unnormal data, we need to make it duplicated based on what is missing. For example, this section name, nama mahasiswa, alamat mahasiswa, and JK. This one has Tiara, and then Ziva and Yorda. So we're here to duplicate the anomaly here, and then we're gonna duplicate this for each of the column. So here when we have Tiara here, we're gonna duplicate the data until here, and then for Ziva will be in here, and for Yodra it will be in here, and the result we'll see like this. This is when we are duplicated the anomaly unnormal data. So this is the first step. For the first form of the step here, we have been accomplished, because the requirement for the first form to be fulfilled is there is no data that has been multi-value, so we can actually duplicate. After that, we're gonna go to the second form. The requirement for the second form is that the first form must be fulfilled. Means we already finished the first step. As you can see, this is the where the blank is, and this is where it has been duplicated based on what is normally missing. And the second, we need to use the dependency, which this one to recreate another section of the table, and then the functionality is based on what the key of each of the attributes. So for example here, the primary of the key attribute is name, and name is based on the nama mahasiswa, alamat mahasiswa, and JK is what's based on name, because name is where you can search find reliable and easy, because without name you cannot see the nama mahasiswa, alamat mahasiswa, and JK. So here we make the dependency functional dependency 1. So we have 3 attributes here that based on the formula. After that, as you can see here, the first functionality dependency here, the first one is based on the primary key here, is the name. Will be followed by the nama mahasiswa, alamat, and mahasiswa JK. The second one is the course code. This course code will be related to the course name and the SKS. So when you see here, the course will be related to nama MK, SKS, and the base on the course code will be teaches by the coder docent. So in here we have actually 4 up to 5 for functional dependency, and then after that the third one is for the docent code. For the lecture code, there will be a nama dosen and alamat dosen. As you can see here, there are 3. And then the last, the functional, is for display, showing the result of the student score, the final score based on their semester. So in order to find this, the score is you need some NIM, code MK, and the semester you have been reached. After, if you accomplish to find this 3 attribute, you will earn the nilai or nilai semester or NSM. So we can see here we have 3 the primary key that we need to fulfill to display the nilai semester. And after that, after we finish making the functional dependency, you can make another table for a second form, which will be like this. This is what happens when you divide it into 4 different functionality. Here we have the functionality for students, and here we have the functionality for the course. In here we have the functionality for the lecture, and this is the functionality for nilai semester or the final result based semester. And we are in the same rules of this primary. Now going to the third one is we are going to delete some another anomaly which that have the same exact attribute based on the functional dependency. To requirement that, we call that as the tendency. So we remove some anomaly here. So based in here, there are several that have the same data, so it's called the anomaly. So for example, the FD2 and the FD3, they have the same name of nama docent. Because this is really specific to the course code, and this is more specifically to the lecture, so we're gonna delete this section here. Now we've successfully deleted this. Now this will became the third of form. When this be deleted, it will be like this. This is the formula that have the primary key based on the rest of the related key attribute. Because as usual, there's these two are the anomaly that have the exact same attribute at the exact same the different functionality, and then it will be deleted, and this is the result of the formula TD, and the end of the result is exact like we said before. This one, it will be deleted completely based on here. And now after we delete the anomaly, and then we gonna delete to another to the BCNF, which you remove the some certain multi-value that have the exact same value in one functionality dependency. So for example, in here they have some couple duplicate data that have the exact same data in this functional. For example, system basis data, they have almost a tree that have the same data. So in here we're gonna delete the data that have the exact same data. So we're gonna delete this, and we're gonna delete this. And there's another one such as algorithm and pemrograman. This is the multi-value, so we need to delete it. And for next searches into the functional tree, here we have the same lecture data, so we're going to erase this. So now we enter the BCNF where we remove some certain multi-value. This one doesn't have any multi-value based on what the data seems, so it's good. This is when the form of the BCNF has been fulfilled. Now it will be clearly the end of the steps of finishing the unnormal data. After we finishing the data here, we're gonna make demonstrate creating the diagram based on the each of the functionality dependency. Now I'm gonna demonstrate how to make one. The first one, we're gonna do exact same as a primary thing here. So the way it display here is the functional dependency is where you can find the result NSM. So we're gonna input first is the NSM. Here are the last of the dependency, and then after that we're gonna search another primary key, which is the name. And then there will be a lecture code, and there is another one is for the semester. I'm sorry, this is not a lecture code, this is a course code. Okay, after that we make this, and this will be the primary meaning when they have the functional dependency here based on the diagram. This one will be the primary, so we're gonna make another table here. This is another diagram. This will be the main flow of each of the attributes. Now here, because based on the rules in here, the functional dependency for NIM, Code MK, and semester are the main in order to display the NSM. So because we have the exact connection arrow, so this will be directly to this one, and I will do the rest. Now for NIM, as you can see from when you show the table, The name contains some nama mahasiswa, alamat mahasiswa, and JK. So we're gonna make three attribute, three entity or attribute. So we have nama mahasiswa, we got alamat mahasiswa, and JK. We have the connection name, the attribute name that consists of these three. So we're gonna make a connection here. This one is name, address, and this one. Next, for the course code, they contain some nama MK, SKS, and kode dosen. So we're gonna name tree here, nama MK, kode dosen, and SKS. And we're gonna make a connection between this dependency alright. And then the last one is for the lecture code. Lecture code was containing some name lecture and address. So in here we're gonna make another entity. This is for a lecture's name, and this is for the address. Alright, now it has been finished. This is the total result of the entity relational diagram. This is how to demonstrate the ER diagram, and this is the way the data table has been formed. Thank you very much for watching, and have a good night.